Welcome to a new test and teardown video. Look at this fantastic pocket oscilloscope, but that's not even what it's called. This one is a Createc SC01, but it's called a signal computer. Really? Signal computer. Holy crap. It's full of buttons and dials and whatnot. I mean, of course you got the two channels like that, and that will be the volts per division. And that is, of course, the two channels of DC, ground, AC. And there is a 5-pin DC connector. And I also got the AC adapter, 3 outputs. And this is, of course, so there is no local converters, regulators, or anything like that. So it saves all that space for all the good stuff in here. And then you have the 3. Ooh, this looks a little dodgy. There is this nice transport cover. I took this off because I think it was about to break, but I'm a little bit unsure if the idea is you just crank it open like that. It definitely feels wrong to do, so I just pulled it out carefully because I don't want to break it. This looks brittle, this old plastic. As you can see here, we got those. Yeah, starts to crack, so I didn't want to break it or anything like that. As you can see here, I don't have the info labels here. They normally say sample rate is 20 megahertz, DC to 10 megahertz bandwidth, 7-bit vertical resolution, and I think that has something to do with the screen. So this is probably a 120 segments or dots, probably 127 by 127 dots in this LCD display, right? And inside the cover here, I found this key sequence chart. And this one is nicely in English. I will have to check this out. Maybe I should scan this and put it on the internet so you can look this up. Of course, googling a little bit more on this unit, and I found an EEVBLOG 1291 video by Dave Jones, and I will send the link in the description to that video, and you should definitely go there and start from 28 minutes. Dave goes absolutely crazy about this unit, and he called it the worst oscilloscope ever. So I can't wait to see if that is really true. I was able to find the manual online quite easily, a German version of the manual. I don't know if there is even an English version. I haven't heard about it. It says it's from Berlin, Germany, and the manual is really good. Full of details on how to use it and what it is and whatnot. It also says it is from January 1990. So at least now we know the exact age of this product. So if I scroll down in the manual, I find something really interesting I want to show you. The first thing is, what is the signal computer because they call it a signal computer. So I use Google Translate with this picture, and then I get a nice English version about what it is. And I think it's a really funny, it's just so fantastic reading, so I have to put it in here for you guys to see. I mean, most of it is a lot of gibberish about what computers are and what computers can do, and then only a few lines of what is it this thing is doing. I think this is just absolutely hilarious. And then we go to the next section. It says, what can this signal computer do? And I also translated this. So it says it can analyze the analog signals, and you can perform calculations and store them and record them and all those fantastic things. So it's not a big surprise if it's a digital oscilloscope, of course. So I can't wait to see if this unit is as bad as Dave claims it to be, the worst oscilloscope ever. So let's turn on and see what happens. Let's see if we can move the light so it gives us an okay picture here. At least we can see what's going on here. So this is the power on screen, and there isn't anything else. I mean, maybe I'll just push a random button. Okay, that's it, whatever random button, and then it goes to the scope features. So I have it here. This is the channel that I have on, and I put in a BNC connector to my oscilloscope. I got 1 kilohertz and 4 volts in, and I got 5 here. So I didn't even push anything at all, and it already shows the signal. So what have we got here? Is this truly whatever we have? 4 volts peak, and I got 5 volt. So this is per division. So what if I turn the 2 volts per division? Then it should be, so it's not. Okay, that is the time it takes to figure this out. What the heck? So what if I go 1 volts per division, and then we wait again? That is amazing. That is how long it takes. And it's just 3 running or something like that, because the horizontal, the time base here is the 299 milliseconds per division, and that is a little bit weird. So now I'll try and hit the auto, and then we'll see what happens if no. And that is the thing with this scope. It is really, really difficult to use. So I think I hit 1 and then M for milliseconds. Okay, we gotta consult the manual, damn it. I think I got a major breakthrough. And I don't know if I want to claim it was the little manual here that made it for me, but it turns out that I find this information here where it says something about how to operate the unit. So you always click channel 1, and then you can click normal, and then you can put in whatever time you want, millisecond or that, and then you can select chop or alternating. So this is how you control the unit. And of course this manual is just one big mistake. It's just full of mistakes. For example, all these thing here where it says chop alternating, X, Y, Y, T, or SP, ST, all these, they are not like this in real world. So if I take my unit here, they're all exactly the opposite way. See, it's called YT, it's called ST, and it's just, see, this is alternating or chop. Everything here is the other way around. So if you really follow the manual, it takes a little bit longer to figure this out. So if I want to change the sweep rate like that, so let's have a look here what I'm doing. It shows on the display what I'm doing. So channel 1, and then I hit normal, for example, it also clears whatever it is after a little while, but then it remembers what I'm doing. So I can just, if I click 1, see, and then milli, and then second, and then I have set the time base. So, okay, you obviously you didn't see anything here because it is already 1. So let's try and do it again. Channel 1, normal, 2 millisecond. Let's see what happens. See, I changed the time base, and obviously the curve also changed immediately. And now it is scanning much faster. You see, we have a more or less instant response to what I'm doing here. See, because I'm now sampling much less data instead of going in the microsecond super fast mode. Then it takes a lot longer time for this unit to update the display. Let's try a little bit of high speed on this one. So this is 100 nanoseconds, huh? And this is a 1 megahertz input sine wave. So let's dial it up. This is 2 megahertz, and it's at this speed here, it goes, as you can see now. So the update is pretty slow. This is 4 megahertz, 5. Remember, it was supposed to be 6 megahertz. Oops, what is, okay. So that is 6. Let's try and push the limit. 7, 8, 9, and obviously we have the alias issue here. So this is 10 megahertz. And since it's sampling 20 megahertz, this is exactly one sample like that, right? So what happens if I give it 12 megahertz? It goes back again like that. And I can probably go all the way to 15. Yes, and that is 20 megahertz, and then we have DC. So let's try and go the other way. 21, 22 megahertz. Obviously, we get a sine wave. Again, now we are on the other side of Nyquist sampling rules. So that will be the 20. That is a sample, and we go back to 10. We have 2 points, and then we have 5. We have 4 points, and then there's of course a recreate filter that makes it a sine wave. How cool is that? So let's try and see what happens if I give it a pulse. So this is my classic 1 microsecond pulse, and I have up here on the input a 50 ohm through termination, and here is my 1 microsecond pulse, and we get the leading edge as well. So that means it tricks and stores the leading edge. Everything here is perfectly fine. I'm actually really happy about this, and it's nice and stable. And in this mode, it's quite fast response. I don't know if you can see, I think it's doing like 3 or 4 updates per second. You can see the pictures moving a little bit. So now I upped the repeat speed of my pulse. It's still the 1 microsecond, but I think you can hear my signal generator goes a little beep beep in the background when I change the repeat frequency, and then try and hear the beep and then look for the update here, right? See, is that? So it's quite, there's a buffer or something like that. It's not this. This is the, yeah, there's a funny lag. Almost a second. So that is it in this 1 microsecond. So what if we go down to milliseconds and repeat this, and let's see then the update speed. So I just divided everything by 1,000, so it should be more or less the same thing that we're seeing, right? So let's try and change the. That is obviously impossible to do. Here we go. And then it's almost I feel now the delay is, so I can more or less accept this. That's interesting. So I'm using my little XY plotter Arduino thingy with the 2 analog output, right? This is the one that shows my YouTube channel name on a scope, right? And of course I find the XY mode in the manual. It is here somewhere, right? And then I'm trying to use the different storage features to see if I can add the different channels together, but that is not possible. And it's driving me a little bit nuts. So I figured out the XY mode is right there. So it's either time or XY. So in XY mode, as you see right here, let me put it in the holder again. Here we go. I just get those random dots. It's not connecting the dots. So connecting dot mode also don't work in XY mode. And it seems like it still runs the 2 channels as individual channels with individual triggers as well. And you have individual time bases as well, even in XY mode. So I really don't understand XY mode so far. So now we'll try and give it 2 sine waves of extreme slow speed and see if I can make a circle or something. It's just not working the way I imagined. Here is something really interesting. I'm back to time mode. Okay, so look at the 2 curves. I got channel 1 and channel 2 in here at the same time, right? And I got a 101 hertz input and I got a 100 hertz input on the 2 channels. So this is different frequency, right? But why is it showing both of the inputs directly like that? So it's because it's triggering on both channels individually and just displaying both channels with individual triggers. It's just amazing it can do that. But it's, of course, it's amazing. So what you can do is you can make it trick only on channel 1. So I think I hit channel 1. And then, yeah, let me see if I can figure this out, okay? 1, trick, and then only 1, and then like that. So, if I am triggering only on channel 1, right? I mean, channel 2 should move, right? But that is not the case. So what is going on here? I need to figure this out. Okay, so now I understand what I can do. So both of the channels, they can trick on both of the channels. So I need to select channel 1, trick on 1, channel 2, trick on 1. So now channel 2 is floating like you see here, right? So now I should be able to go into XY mode and yay! I get a little rotating circle. How about that? That is about time. So now it's moving, yay! It's not that difficult once you figure this out. Oh, I think I got a little breakthrough here with the XY mode. So what I'm doing is now I'm zooming in on the time scale, and then I can go to XY mode, and it is a lot better. But there's still a little fun thing with the updates. As you can see, it goes a little bit live, and then we have some really weird delays. It's not moving nice and fine. There's some funny thing going on with XY mode. But this is actually a classic thing with digital scope, and XY mode is always terrible. So why would this one be any different? It's using 6.9 watts from the mains socket. So you would think this is not so much, but this power supply here runs so warm you can't even touch it on the outside. So I need to touch it like here and here, and it's crazy warm. The transformer core here is like smelling like burnt something, and the 3 voltages, that's made by 3 regulators. Here's 1, 2, and 3, and it's just crazy warm. What the heck is going on here? So is it... It is of course designed for only 220, and I gave it 232, so I should not do that. There is a thermal... a thermal fuse right there, and that one will trip at 130 Celsius, it says right there. So this is good for burn down protection. Sweaty. I should maybe document the different voltages in this connector, because I got a unit here that is working and I don't find any documentation about that. So that could be a good idea to write this down. It looks a little bit like a DIN connector, but it's not exactly that. So here's the documentation for this power plug, and this is how we look at it. We're looking into the male power connector. All right, so this is important. And there's a marking right there, and this is where the cable goes. So the point here is the 5 volt, 0 here and 5 volt here, those 2 pins, they are not connected to the plus 12, 0 or minus 12, completely floating. And that's of course because we got no local regulators or anything inside the oscilloscope, and this is why they are directly connected in there. This is where you make the common grounds, so to speak. So voltage drop over the cable and in the connector and all that is not causing any problems. Also, if you pull the connector or plug it in with voltage applied, I mean, you're not gonna blow up any 5 volt system. You can imagine what happens if you release this one first and these two are connected together. You can of course blow up stuff. So this is why they did it exactly like this, to make it safe to pull the plug, so to speak. So I have figured out how to open this thing, and here's what I did. You can see it's transparent right here, and you can actually right here in the middle of the picture, can you see the screw? And there's another one right there in the middle, and there's one right there, and I believe right there. So the point is, what they did is they screwed this transparent plastic down on top of the circuit boards, displays, and all that kind of stuff. And everything here is one piece. This is one shell, one piece, and this end plastic here goes all the way down, slippity slip, tight fit, and all that. And when the screws are all tight and all fine, then they glue stick this aluminium sheet with all the text and fancy things down into a little groove, as you can see here. So it's a little bit down. So if I really want to open this, I need to crack open this aluminium and bend it and destroy it to be able to access those screws. And since it is so nice and beautiful and it really works fine, I am not going to destroy this unit just to show you what is inside. I am sorry, but I love it too much. And I don't think this is a really shitty scope. It's different, very different, but all you need to do is read the manual, spend a few minutes on that. You will be able to understand it. once you get all this thing with the little triggers, and once you get the thing with the two completely isolated, stand-alone channels with triggers and time bases and all that, that's completely individual. That is definitely something I have never ever seen before. I don't even know what you can use this for. You always want to compare one channel to the other one in the same time scale, right? But this one, of course, you can select the same trick and all that, but it's not what it does per default, definitely. So anyway, that is what I wanted to show you about this fantastic oscilloscope. So please come back again soon, and bye and all that.